every type of exotic matter. Space is complicated. We make it simple. Everything you've ever touched, eaten, or breathed is made of ordinary matter, protons, neutrons, and electrons, obeying rules that have held up in every laboratory experiment ever conducted on Earth. Ordinary matter, by the best current measurements, makes up less than 5% of everything that actually exists in the universe. Every category on this list is a serious, real proposal for what fills the rest of it, or for material so strange it breaks rules ordinary matter simply can't. We're going in order from the most observationally confirmed to the most purely theoretical. Then we'll sort them a second way by whether we've actually detected it, because on this list makes up most of the universe and directly observed turn out to be two very different categories. Dark matter. We begin with the most observationally supported entry on this list, even though not a single particle of it has ever been directly detected in any laboratory on Earth. Dark matter is inferred entirely through its gravitational effects. Galaxies rotate at speeds that shouldn't be possible given only their visible mass, and without a large amount of additional unseen matter providing extra gravitational pull, the outer stars in every spiral galaxy we've ever measured should simply fly apart. Here's the fact that should genuinely bother you. Dark matter appears to outweigh ordinary matter by roughly 5 to 1 across the universe as a whole, meaning the stars, planets, and gas that make up everything visible in the night sky are, gravitationally speaking, a minority passenger riding along inside a much larger, completely invisible structure. Multiple independent lines of evidence, galaxy rotation curves, the bending of light around galaxy clusters called gravitational lensing, and the specific pattern of ripples in the cosmic microwave background all point to the same missing mass measured through completely different methods, which is exactly why most physicists consider dark matter's existence extremely well established, even while its actual particle identity remains one of the most stubborn open mysteries in all of physics. Dark energy. Here's the twist. Dark matter's gravity holds things together. This next entry does the opposite, and it's even more dominant and even less understood. Dark energy is the name given to whatever is causing the universe's expansion to accelerate, rather than gradually slowing down under its own gravity the way early cosmologists originally assumed it should. Discovered through observations of distant type Ia supernovae in the late 1990s, dark energy appears to make up roughly 68% of the total energy content of the universe, dwarfing both ordinary matter and dark matter combined. Here's the fact that should genuinely bother you. Nobody has a confirmed explanation for what dark energy actually is. The leading candidate treats it as a property of empty space itself, a cosmological constant built directly into the fabric of spacetime, causing new space to be created between galaxies at an ever increasing rate. But the predicted strength of that effect, calculated from quantum field theory, comes out roughly 120 orders of magnitude too large compared to what's actually observed, a mismatch so enormous that physicists sometimes call it the worst theoretical prediction in the history of science. Here's the part that lingers. Dark energy's dominance is only getting stronger over cosmic time, meaning the fraction of the universe made of this completely unexplained force is actively increasing every single day, pushing every galaxy not gravitationally bound to our own farther away faster the longer the universe continues to exist. Antimatter. Here's the reframe. Unlike dark matter and dark energy, this entry isn't inferred indirectly. It's been created and studied directly in particle accelerators since the 1930s. Every particle of ordinary matter has a corresponding antimatter partner, identical in mass but opposite in electric charge. And when a particle meets its antimatter counterpart, both are instantly converted entirely into energy in a process called annihilation. Here's the fact that should genuinely bother you. The standard model of physics predicts that the Big Bang should have created almost exactly equal amounts of matter and antimatter, which should have mutually annihilated each other completely, leaving behind a universe of pure energy with no matter left over to form stars, planets, or anyone to ask the question at all. And yet, here we are. A tiny asymmetry on the order of one extra particle of matter for every billion matched pairs, is believed to be the entire reason any matter exists in the universe today. And physicists still don't have a complete confirmed explanation for exactly why that asymmetry happened in the first place. Here's the part that lingers. Antimatter itself is now one of the most expensive substances ever produced by humanity, generated in only microscopic quantities at facilities like CERN, meaning the same material responsible for the universe's entire existence, in the form of why isn't everything gone, is also something we can currently manufacture only a few billionths of a gram of at a time. Strange matter and quark matter. Here's the pivot. This is where the category moves from invisible to physically bizarre, describing matter built from fundamentally different rules than the protons and neutrons making up everything around you. Ordinary protons and neutrons are each built from up and down quarks, but under sufficiently extreme pressure, such as inside the crushed core of a neutron star, some physicists propose that up and down quarks could be forced to convert into a third type called strange quarks, forming an entirely different, theoretically more stable configuration of matter called strange quark matter. Here's the fact that should genuinely bother you. Some models propose that strange matter, if it exists at all, could be so stable that it would convert any ordinary matter it directly touches into more strange matter in a runaway chain reaction, a genuinely unsettling hypothetical property, sometimes referred to as the Ice Nine scenario, borrowed from the fictional substance in Kurt Vonnegut's novel Cat's Cradle. Here's the part that lingers. This exact worry was seriously formally evaluated by physicists ahead of high energy particle collision experiments at facilities capable of theoretically producing tiny quantities of strange matter, and multiple independent safety assessments concluded the risk was effectively negligible, but the fact that the question had to be seriously studied at all tells you something about how strange the theoretical properties of this specific category of matter genuinely are. Exotic matter with negative mass or negative energy density. Here's the fact that pushes this list from strange but real into territory most physicists consider purely mathematical. Several major theoretical proposals in physics, including traversable wormholes and the Alcubierre warp drive, require a form of matter with genuinely negative energy density, meaning it would need to gravitationally repel rather than attract, behaving in a way completely opposite to every form of matter ever directly observed. Here's the fact that should genuinely bother you. This isn't pure fantasy. A real laboratory confirmed phenomenon called the Casimir effect demonstrates that the quantum vacuum between two extremely closely spaced metal plates can exhibit a form of negative energy density in a small, carefully controlled, and vanishingly brief experimental setting. Here's the part that lingers. The enormous gap between a measurable negative energy effect exists in a laboratory for a fraction of a second, across a gap smaller than a human hair, and enough stable exotic matter to hold open a wormhole large enough for a spacecraft, is, by most physicists' own admission, so large that nobody currently has a credible engineering path connecting the two, even though the underlying physical principle has technically already been confirmed to exist in some form. Mirror matter. Here's the twist that reframes what invisible could actually mean. Some theoretical physicists have proposed that dark matter isn't a single new type of exotic particle at all, but an entire parallel version of ordinary matter, sometimes called mirror matter, built from a duplicate set of particles that interact with each other through their own version of gravity, electromagnetism, and nuclear forces, but interact with our own version of matter almost exclusively through gravity alone. Here's the fact that should genuinely bother you. Under this theory, there could be an entire complete mirror version of chemistry, and even mirror stars and mirror planets existing throughout the universe, invisible to us not because it's fundamentally strange or empty, but because it's built entirely from a version of matter that simply doesn't interact with light or with any of our detectors the way our own matter does. Here's the part that lingers. Mirror matter remains one of several competing candidate explanations for dark matter's true identity, and unlike some purely mathematical proposals, it makes specific, at least partially testable predictions about subtle effects in particle physics experiments, meaning it hasn't been rejected outright, even though it also hasn't found the kind of direct confirming evidence that would move it from one serious candidate among several to the accepted answer. Tachyonic and superluminal matter. Here's the fact that closes this list on its most purely mathematical, least physically supported note. A tachyon is a hypothetical particle that, according to certain interpretations of relativistic equations, would always travel faster than the speed of light, the mathematical mirror image of an ordinary particle that can never reach light speed at all. Here's the fact that should genuinely bother you. Tachyons aren't simply fast particles in the way that sounds intuitive. The math describing them implies deeply strange properties, including the possibility that a tachyon could carry negative mass squared, a value with no straightforward physical interpretation at all, and that accelerating a tachyon further would actually cause it to lose energy rather than gain it, the complete opposite of how acceleration works for every particle ever actually observed. No experiment has ever detected a genuine tachyon, and the overwhelming consensus among physicists is that they most likely don't exist as real physical particles at all, remaining instead a mathematical curiosity that occasionally pops out of certain equations, taken seriously enough to be formally studied and ruled out repeatedly, rather than taken seriously as an actual prediction about the contents of the universe. Magnetic monopoles. Here's the fact that closes this list with one of the oldest, most stubbornly unconfirmed predictions in modern physics. Every magnet ever observed, from a refrigerator magnet to the largest neutron star, has two poles, north and south, and cutting a magnet in half simply produces two smaller magnets, each with its own pair of poles. No experiment has ever isolated a single standalone magnetic pole on its own. Certain grand unified theories, which attempt to merge electromagnetism with the other fundamental forces of physics, predict that magnetic monopoles, isolated single pole magnetic particles, should exist somewhere in the universe, likely formed in extraordinary numbers during the earliest fractions of a second after the Big Bang. Here's the fact that should genuinely bother you. Theoretical calculations suggest monopoles should be common enough that their expected density, based on standard Big Bang cosmology alone, would actually be high enough to noticeably affect the mass and structure of the universe, a mismatch between prediction and observation, sometimes called the monopole problem. And one of the specific issues, cosmic inflation, was originally proposed in part to help resolve by diluting any monopoles formed in the earliest universe down to a density too low for us to have ever detected one since. Here's the part that lingers. Despite decades of dedicated searches, including specialized detectors built specifically to catch the unique signature a passing monopole would leave behind, not one has ever been confirmed, making the search for a single isolated magnetic pole one of the longest running null results in the entire history of experimental physics. Let's sort these 8 again a different way, not by how exotic they sound, but by whether we've actually detected them. On the confirmed real end, antimatter, directly created, measured, and studied in laboratories for nearly a century, no theoretical argument required at all. On the overwhelmingly evidenced but never directly touched end, dark matter and dark energy, both supported by multiple independent converging lines of observational evidence, despite neither one ever having been directly captured or isolated as an actual particle or substance. On the theoretically motivated but unconfirmed end, strange matter and mirror matter, both mathematically consistent, both taken seriously by working physicists, and both still waiting for a single confirmed detection to move them out of pure hypothesis. On the partially demonstrated in miniature end, negative energy density, technically confirmed to exist in laboratory conditions through the Casimir effect, but nowhere near the scale any practical application would require. And on the almost certainly fictional end, tachyons, mathematically derivable, formally studied, and essentially unsupported by any physicist's actual expectation that they represent something real. It's worth being clear before we close about the actual scale of the search effort behind every entry on this list, because it's easy to assume these remain open questions purely from a lack of trying. Dedicated dark matter detectors sit in mine shafts kilometers underground, specifically to shield them from interfering cosmic radiation Particle accelerators smash protons together at nearly the speed of light, partly hoping to glimpse evidence of strange matter or monopoles. And satellite observatories have spent decades mapping the cosmic microwave background specifically to pin down dark energy's exact behavior. Here's the fact that should genuinely bother you. This represents one of the largest, most sustained, most expensive coordinated search efforts in the history of science, spanning multiple generations of physicists and multiple entire fields of specialized instrumentation, and it has still only confirmed the existence of one single entry on this entire list directly. Everything else remains inferred, theorized, or briefly glimpsed only in the smallest, most fleeting laboratory conditions. Here's the last thing worth sitting with. The ordinary matter making up you, this planet, and every star you've ever seen in the night sky is, by the best current measurements, a small minority stakeholder in a universe dominated by things we can't directly touch, can't fully explain, and in some cases have only proven exist for a fraction of a second inside a laboratory smaller than your hand. Everything you have ever personally experienced is built from less than 5% of what's actually out there. Not bad for stick figures on a rock,